Okay, you're listening to 13.6, lesson 13.6, also can be found on page 875 of your textbook. Learning target for 13.6 is I can describe and compare data using measures of center, mean, median, mode, and spread, range, and mean absolute deviation. So today we're talking about averages pretty much, okay? Friendlier term, averages. We are going to talk about center averages, so that would be your mean, median, and mode, and then we're also going to talk about spread averages, that would be your range and mean absolute deviation. So of the 5 different types of averages we're going to take a look at, you've probably heard of 4. The 5th one that's new for you today is probably the mean absolute deviation piece. Okay, so let's take a look at the 3 different measures of central tendency. Okay, measures of center averages. There are the 3 M's here, and the mean, median, and mode. So mean, often called average too, would be for the data set x1, x2, x3, so on, so on, so on, so on, so on, all the way to x to the n. Mean is usually given by this symbol where it says x and then there's like this bar above it. This is called, it's read x bar actually. Whenever you see this symbol in a graphing calculator, when we do our graphing calculator activity here, that actually means the mean, okay? The average mean. So what is the average? How do you calculate the average mean? The average mean then is calculated. This is where you take your values, all your data points, so x1 plus your x2 plus your x3 plus your all the way to your plus your x to the n power, whatever your last x is. Then you're going to divide it by how many data pieces you added together. So xn being your last term, well, if I have 1, 2, 3, 4, or n terms in my data set, I'm going to divide the sum of all the data numbers divided by that same, but divided by n, the number of numbers in your data set. Okay, so that is kind of your formula. Add up all the numbers divided by how many you added. Median. Median is the middle number when you write your numbers in numerical order. If the data set has even number values, the median is the mean of the 2 middle values. Okay, so put all your numbers in order, find the middle number. That is your median. Okay, your middle number. Think of it as the middle. So it's really easy to find a middle number when you have odd number of numbers, okay, because there's just a single middle number. But if you have even set of numbers, you're going to have 2 middle numbers. You need to find the mean of the 2 middle values. So that would be your, your x1 plus your x2, because there's going to be 2 middle numbers, and divided by 2. That will give you your median. Okay, and then we've got mode. Mode is the value that occurs the most frequently, often referred to MO, mode. Value that occurs most frequently, so think of most, mode. And there can be one mode, there can be no mode, or there can be more than one mode. Okay, so keep that in mind. Sometimes in a data set here, there's only one number that appears more than the other ones. Okay, there could be one mode. Maybe all the numbers appear the same amount, so there could be no mode. And there could be more than one number that appears the same amount of times, so there could be more than one mode. So let's take a look at an example here. Example below, the heights and feet of 8 waterfalls in Washington are listed. Which measure of central tendency, so which measure of central tendency, remember we just talked about the 3 measures of central tendency, your mean, median, and mode here, best represents the data. So we've got 8 numbers here, 8 data points, all representing the waterfalls that are, how high the waterfalls in Washington are. Notice that they're all in numerical order already here, so that makes it a little bit easier. So let's do, in order, let's do the mean first. So what you're going to do right now, you're going to pause this. Hopefully you have a calculator at hand. You're going to go ahead and add up all 8 of these numbers together. Because remember, mean is add up all the numbers together. So we're going to get a total up here. And then we're going to divide it by how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8. Oh, we already knew that. There were 8 waterfalls. And that is going to give us our mean. So go ahead and quickly pause this, add it up, and unpause it to see if you got your total correct divided by 8 to calculate your mean. Ready? Pause. And you're unpaused. So you should have added all 8 of these numbers up. It should have added up to be 10,752. You take that divided by 8. You're going to get your mean. Remember, X bar means mean. You should have your average to be 1,344 feet. So the average height of all 8 waterfalls, if you add them all together and divide by 8, is 1,344 feet. Okay, let's do the second one. The second measure of central tendency would be the median. The median is like the middle number. So I did some of the work for you already, or the data points are already in order, so that saves you that first step. Okay, so they're in order from smallest to biggest, and all you have to do then is, because there's 8 numbers here, I know I'm going to have 2 middle numbers, so I'm going to go 1, 2, 3, 1, 2, 3. These 2 are my middle numbers. So in other words, I have to find the middle of my 2 middle numbers. So I'm going to find the mean of the 2 middle numbers. So I'm going to add up 1191 plus 1200, and I'm going to divide it by 2. That ends up to be 2,391 divided by 2. That means my median in this case is 1,195.5 feet. So putting all the heights of the waterfalls in order, the middle height would be 1,195.5 feet. And then last measure of central tendency, that would be your mode. Remember, most. Which number appears the most? Well, if you look at this data here, after I erase some of this, any of these numbers appear more than one time? Well, if you look here, 1,000 appears 2 times, and no other number appears more than 2 times here. So our mode in this case would be 1,000 feet. So let's answer this last question then. Which measure of central tendency best represents the data? Well, if you take a look, we have 3 different numbers happening here. We have the mode, which is 1,000. We have the median, which is 1195.5. And then we have our mean, which is 1344. Okay? 3 different numbers here. If you take a look at our number, you can take a best shot here. I mean, there is really no wrong or right answer. There is a best answer, though. Which of these 3 best represents our data? Well, if you look, our mode is on the minimum side of our data set. Our mean here is in the upper end, 1344, which falls between the last 2 top numbers. And then we have our median, which is our middle number. So which one of these 3 numbers tends to best represent this data? I would go with the median. Okay, we would write median best represents this data. Because it's in the middle. Okay, because it's in the middle of the data, because it's in the middle. Okay, it's not weighing in on the high end, it's not weighing in on the low end like the median and mode were. Okay, now so that was basically the 3 different measures of central tendency: mean, median, and mode. Hopefully you took that kind of as a review. Okay, let's take a look at the 2 measures of dispersion. Okay, measures of spread. Dispersion means to spread. Okay, so we're going to look at 2 different calculations that calculate the spread of numbers. Rather than the averages, it's kind of the spread. It's a different type of average. The first one you've probably heard of. It's the range. Okay, how do you calculate the range of something? It's the difference of the greatest value and the least value. So take the smallest value, take the largest value, subtract them from each other. What is the difference between the 2? You've got your range, your spread of your data, biggest to smallest. Okay. Then we've got something called, here's the newbie one, it's called the mean absolute deviation. Okay? So it has the word mean in it. So at some point you're going to calculate the mean of the data. And then the new part is the absolute deviation part. Okay, so what it means is it's your average spread of the data from the mean. Okay, if that makes any sense to you. It's a different kind of average. It breaks it down even more. So there's 2 steps to calculate mean absolute deviation. Your first step is you have to actually find the mean first. Okay, so find X bar. Remember, X bar means mean. Let's write this in here. This means find the mean. Okay, then your second step is you have this awesome formula that I've already copied down for you so you don't have to miscopy it just in case. How do you calculate the mean absolute deviation? Well, it's equivalent to, it's a fraction bar. You're going to take the absolute value, you're going to take each data point and you're going to subtract the mean from it. So take the first data point, subtract the mean from it, and you want the absolute value of that. Add it to the second point subtracted from the mean, the absolute value of that, and then keep adding on. It's going to be the sum of the, let's see if I can say this correctly. It's going to be the sum of the absolute values of each data point subtracted from the mean. And then last part you have to remember, after you've added all those sums up, you've got to divide it by how many different data points there were. Okay? So let's use the same data numbers, the 8 waterfall heights from Washington, to find our 2 measures of dispersion, 2 measures of spread. So we're going to find our range and our mean absolute deviation. The mean is the easiest. Sorry, not the mean. The range is going to be the easiest here. So let's calculate, I was going to write mean again. Let's calculate range. Big minus small. So I'm going to take the biggest number, 2,584, subtract it from the smallest waterfall height, and our range here is going to be 1,584 feet. Okay, so the difference from the shortest waterfall to the tallest waterfall is 1,584 feet. All right, now what we're going to do is we're going to do the mean absolute deviation. So I'm going to abbreviate this so I don't have to write down the entire name of this. I'm going to call this the MAD. Okay, because this is going to make you mad because it's so much work. So think of it that way. It's the mean absolute deviation. So it looks like our first step in calculating the mean absolute deviation is we've got to calculate the mean of this. So again, I'm going to have you pause, grab your own calculator, add up all 8 data points here. Okay, that's going to give you this number on top, and divide it by 8 because that's how many data points there were. So go ahead and pause. Divide by 8, unpause, and see if you got the same value as I did. Okay, so hopefully you got a total, when you added all 8 waterfalls up, you got a total of 10,752 divided by 8 because there are 8 numbers in that data set. You should have gotten a mean of 1,344. And come to think of it, we already calculated that up here. Huh. Well, anyways, you just got more practice if you actually didn't realize that like I didn't. Okay, second step is, now that we have the mean, now we can use this awesome formula to calculate the mean absolute deviation. Okay, so I've already set this up to get myself ready for this. This might take up a little bit of room here. So I know that I have 8 numbers here. So in my data set, I have 8 absolute value bars set up here. So here's one set, all being added together. Here's a second set, third set, fourth set. And each one of these absolute value bars, inside, I'm going to take each data point, okay, and I'm going to subtract the mean from it. So to start off here, I'm going to go ahead, take my first data point, which is 1,000. I'm going to take 1,000, because that's my x1, and I'm going to subtract it from my mean. So 1,000 minus my mean, which is 1,344. Okay. My second data point, another 1,000. So I'm going to take my 1,000 and I'm going to subtract it from my mean again. So each one of these absolute value bars here, I'm going to end up adding all of them together. So I'm going to take my third data point, 1,181, subtract it from my mean. Take my fourth data point, 1,191, subtract it from my mean. My next data point, 1,200, subtract it from my mean. Next data point, 1,268, subtract it from my mean. Seventh data point, 1,328, subtract it from my mean. And last data point, which is 2,584, subtract it from my mean. Whoops, 13, well, 1,344. Okay, so I have them all set up in their absolute value bars. Okay, so keep in mind I am only doing this top part right here. Okay, taking my each value, subtracting from my mean. So what I have to do now is I'm going to do order of operations here. I'm going to subtract subtract inside each one of these absolute value bars and then take the absolute value. So for example, my first set here, 1,000 minus 1,344 ends up to be negative 344. But consider the absolute value bars. This is going to end up to be 344. Next set, 1,000 minus 1,344 is negative 344. But take into account the absolute value bars, I'm going to get 344. Okay? 1181 minus 1344 ends up to be negative 163. But absolute value makes it positive 163. 1191 minus 1344 ends up to be 153, negative 153, but absolute value bars makes it positive 153. 1200 minus 1344 is negative 76. Oh, no, sorry. 144, negative 144. I'm going to make it absolute value bars, so positive 144. 1268 minus 1344 is negative 76, so I'm going to make this positive 76. 1328 minus 1344 is negative 16, so it ends up to be positive 16. And last one, 2584 minus 1344, the only one that's bigger than the actual mean, ends up to be 1,200, or 1240, 1,240. Okay, so all I did there was subtracted each number from the mean, subtract the mean from the number, found the absolute value of them, and now what I'm going to do is I'm going to add up all of my sums here, all of my calculation, my absolute value bars, my absolute value numbers here. So 344 plus 344 plus 163 plus 153 plus 144 plus 76 plus 16 and plus 1284, that ends up to be a total of 2,480. Okay, so all we did was that top part. Now remember, the second part to this formula here is it's actually a average here. So all we did was calculate the absolute deviation of them, but then we have to divide it by the number of values we had. So I have to take this, divide it by 8, because I have 8 numbers in my data set. There's 8 parts, 1, 2, 3, 4, 5, 6, 7, 8, and that ends up to be 310. So this mad data point, mean absolute deviation, ends up to equal 310. That means, basically what that means in a nutshell, what you just calculated is each one of these data points that you come up with is about a 310 spread, on average, from the mean, okay? So that means 1,000 is about 310 from the mean. This 2584, about 310 spread from the mean. But again, it's averaged out, so not every number looks like it's actually 310 difference from the actual mean. That one is the biggest formula. That one you really have to keep track of. A lot of people tend to just do all of this absolute value stuff, and we forget then to divide it by 8. Don't forget that last part, divide by 8. Okay, that was a lot. So let's go ahead and give you your summary, and you can practice your 5 different measures of spread or central tendencies here to practice. Okay, remember mean, median, and mode. They measure the center of the data, pretty much like the average. Okay, give you the middle number here. And then range and mean absolute deviation, which we have, or I have given you the permission to abbreviate with MAD, measures the spread of the data. Okay, how much the data is spread out, because some data is really spread out and some data is just really not spread out, kind of just a tight range, tight bunch of numbers kind of together. All right. Anyways, I am done. Thanks for listening. and sample is here.